So I just bought a RipCurrent S that is completely dead. This is the battery pack. The battery pack does not turn on and is a paperweight. So we're gonna see what's up. Okay. First thought was maybe it's the charger. That's not the case. Charger is fine. Second thought, it's gonna be something in the battery.
The battery would not charge, so I ended up taking it apart and down to the cell level. So I had to rip everything apart, disconnect everything. Had to be kind of careful here. It is a live battery still, even though it's only at 17 volts. And here I'm just checking the voltage of the battery pack. So that's not 3.6 volts, that's 361 millivolts. So from my understanding, essentially anything under 500 millivolts, you can kind of consider that cell to be completely dead. There were a couple of strings that were sitting at 2.8 volts, which was cool, and I was able to get some cells off of that. But most of the cells are completely dead, as you can see here. And I just decided to strip everything off down to the cell level. All right, we're back in the studio. These are our dead cells, and I have 24 good cells. It's kind of disappointing. I was hoping to get the RipCurrent S and fix the battery and fix the bike itself. I was able to fix the bike, but the battery was completely gone. Bad cells. So many bad cells. I can't charge them, I can't get them, can't bring them back to life. Unsurprising, since they were under 400 millivolts. The batteries at 2.8 volts, however, they were able to charge, and they charge to capacity. These battery cells are actually 3200 milliamp hour cells. So I did a test to see how much capacity they were actually at. They're actually sitting around 2550 to 2600 milliamp hours. That's only 80% capacity. Now, I don't know enough about lithium-ion cells to tell you whether or not these are good or bad, or if they have any life left. I don't know how much life these have left. 80% capacity is considered end of life for a battery cell. So, I don't know what happens past 80%, if they degrade faster than a battery that's sitting at 96%, because I've been considering mixing these with some other cells, other used cells that I have, that are 2600 milliamp hour batteries, but they actually have a full capacity. So these are 2600, but they used to be 3200. So I just don't know if these will degrade faster. I'm assuming they will. I don't think the curve is going to be that pleasant for these. So maybe if I have like a small battery project, I'll add these to it just to kind of see what that looks like. That would be very experimental. But all I would have to buy is like a BMS, and then I could just connect it up and it wouldn't be an issue. So that's kind of the thought process there. So instead of trying to use my bad cells for the battery, obviously these are dead, I have another 52 volt battery that I'm going to connect to that e-bike, and then I'm just going to do that. So a quick little time lapse of me just connecting up the battery, and then I'll see you next time. So I've got everything wired up. So essentially what I did is I pulled this piece off, and I pulled it off from here. There's two screws, there's one screw hiding, and then I just extended this to an XT60 and then dropped it off to an XT90. All right, I'm just gonna button it up, essentially just plug it in. I'm gonna throw the battery on the back here like that. I considered putting this back on it so it'd have a different look, but maybe not. Maybe I'll just wrap this section in tape or something. We've got a little tape on there. We have this connection that comes up into the battery. Put that down. The battery just sits in the rear. It charges just fine. We're taking a look at the charger. Charging just great. It looks good. 53.4 volts and charging. So it all works. Everything's great. Seems to be working just fine. I need to resolder this. This is not working right. I need to redo all this cabling over here, but
for the most part.
It looks great. So thanks for watching, and I'll see you in the next one. Bye now.